positions is Science, Advocacy and Global Trial Manager. So I'm in a role of science management. So I make sure that I support some question or challenging questions. And with the trial management, because we have many trials running, and our outcome of all of our knowledge is from trials, it's kind of to supporting scientists where they need help with databases, how to interpret it, and somewhere where I'm needed. So I'm in close cooperation with many scientists, of course, but also from the colleagues from commercial side or regulatory department, because it's very important that everything is connected and that we do research in the right direction, which corresponds with the need of our customers or the need of the specific area what needs to be solved.
Your own research has largely focused around antibiotics and antibiotic resistance, if I'm correct about that.
Yes.
So today we're talking about the microbiome, gut microbiome, and its context with you specifically, and its context specifically with you to antibiotics.
Yes.
So you have a term which is gut functionality challenges. What types exist? Tell me a little bit about that.
No, our gut is very complex. There are many bacteria and they need to talk to each other, sending different systems, and they also signals also they send signals also to the brain, and it's quite complex community that support us to survive. Without gut microbiome, we wouldn't be able to digest our food. We're kind of a one ecosystem together with gut functionality, so it's really important. But it's about challenges. It's about if there are some problems. And if I combine, as you mentioned, my topic of antimicrobial use and resistance and gut challenges, then I would like rather go into direction bacterial challenges. So there are, if we have different animal species, we can still see that there are some pathogenic bacteria that cause problem everywhere. And very often they are present in the gut. They are not like, the gut is not sterile, it has also pathogenic bacteria. But if there are some, not disharmony or something happens, change of feed for the animal, or maybe even transportation or stress or whatever, there is a disbalance. And sometimes there is a, biologically that pathogenic are coming into the play of the gut. And this disbalance very often causes diseases that need to be then treated with antibiotics. So with the gut bacteria, we have E. coli, Salmonella, Campylobacter. For swine, it's also very relevant, Brachyspira lawsonia. So there are some bacteria that are part or of the cause why there are some challenges, gut challenges. And actually, we are very, very successful at using antibiotics to manage these challenges, which is great. Antibiotics are really important. They were discovered around 100 years ago, very successfully used for animals, of course for humans, but also for animals. And we would use them forever. Antibiotics are just great because they were really supporting us with treating diseases, bacterial diseases. The problem is always that bacteria get resistant and antibiotics lose their efficacy. So we are at risk that in the future we may not treat bacterial diseases and also manage, in this case, gut challenges as we were using in the past. And that's why we need to have other approaches to make sure that antibiotics are effective. Not that, there is resistance zero, it's not possible, never will be, right? But we want to make sure if antibiotics are needed, if animals are sick, that they can get the treatment, and same for humans. We absolutely, same. We want to rely on antibiotics if we need them.
So, as of today, how big is the issue of antimicrobial resistance in agriculture right now?
Antimicrobial resistance, we call that one health issue. Why? because we live in one ecosystem, right? And we have antimicrobial use for humans as well as for animals. And then because we live in one environment, there is antibiotic use or antibiotic substances that are in the environment, but also resistant bacteria, right? In agriculture, if you look on the map, there are some publications where antibiotics are used. We can see they're used majority in the regions where we produce our animals. Majority of them are used in swine and then in poultry. So we know there is a use. And then there are many data available on the resistance level. So we know antibiotics were used, so what? Then we need to, there are many monitoring studies, for example, European Union. They have veterinarian monitoring studies where we can evaluate what is the resistance level to different bacteria, to different antibiotics, that we understand where do we stand. And that's essential, because if we don't measure, how do we improve, right? And this monitoring in certain regions like Europe, US, we have also monitoring in Japan, for example. We know very well what do we use, what is the resistance level, and then it's easy to develop a strategy. How do we move forward? What to reduce? Where? And taking account all of that, we also need to keep in mind that animal producers are doing a very important job of feeding the world, right? We eat meat, and that's a very important protein source for us. And we need to do it responsibly. So if we just take antibiotic out, you can imagine we can have disease outbreak or mortality. So it's important to make it in a responsible way, to make sure to identify why is antibiotic used, and then to see what is the resistance level in my region. It's easy to detect. We also saw that if there are no monitoring studies, there is a lot of data from the scientific side, so that we can see, okay, I know I use enrofloxacin for my chicks first days, and I live in a region where resistance to enrofloxacin is around 85%. Then the question arises, is it reasonable to use it or to continue use it? Is it really helping? Of course, we can then double the dose and so on, but where does it drive? So it's important to have a sustainable solution in place.
You already pointed a very important point here. There are different classes of antibiotics, correct?
Yes.
So in that context, which classes are considered more problematic and which are considered less problematic in that correlation between use and resistance?
Mm-hmm. The classification of antibiotics, what I mean is now very important, not on the use resistance side, but it's more on human and animal side. Mm-hmm. Because resistance issue is very important to keep humans alive and to have the efficacy in the future. So, and basically, we were using in the past same antibiotic, we still are to the majority, right? And how do we make sure that there are the use is different? And that's why our categorization is. So we have a categorization for animal use, for highest priority critically important antibiotics, high priority critically important antibiotics, and so in general, and important antibiotics. So in general, there are 4 classes of antibiotics where we say, okay, class A shouldn't be used in animals at all. There are some exceptions for pets. Then class B, it should be used as careful as possible, where, for example, we have third generation cephalosporins, fluoroquinolones, and polymyxins. And then we have D, which should be still restricted, and then the prudent use, and also and other antibiotics like tetracycline that can still be used. So it's kind of, we use category D, and then if it doesn't work, we go to C, and then we go to B, and that's it. And there are also, this year report shows that, example, in the European Union, predominantly we use antibiotics of category D. So it's good. We're in a good way to make sure that we use for antibiotics for animals. Not those that need to be really critically important for human use.
Okay.
Or at least we still use others, but at least we balance it more like out. Like the antibiotics that should be necessarily are needed for human use should be reduced on animal use. So it's not like switch from one day to another, use and no use. It's just okay. We reduce here and we understand what is needed for human side. So this is therefore the categorization.
Okay, very interesting. So basically, we have an overlap of antibiotic use between human health and animal health, which we are trying to separate completely. So we can be sure that human application of antibiotics has not, or the antibiotics we use for humans ideally have not been used en masse in antibiotical treatments in animals in order to avoid resistance buildup that then might affect the human health level. Is that correct?
Not quite.
Not quite.
Yes, because we kind of lacking of such antibiotics.
Okay.
If we would have a privilege
Mhm.
to have antibiotics that can be used for animal only, and those are not used in humans at all, that would be great. But it's not the case. Where the separation is on the very, very critically important antibiotics for humans, we try to use those, not to use those in animals, but all others are used kind of cross.
Okay.
Yeah.
So what I've described there is a best case we hope to work towards to, and might end up one day with new antibiotics. But right now the world is a little bit more complicated.
Absolutely. There are many efforts from various perspectives to reduce antibiotic use. Sorry, to develop new antibiotics. Yeah. But this is not easy, right? Because the development pipe of antibiotics was quite dry last years.
For many
now,
reasons.
Now through several initiatives we have more a little bit, but also if we develop a very new antibiotic, so then it goes right to the human medicine, very restrictive use, very very targeted approach.
Little sidestep from my side. Yeah. I'm personally interested what you think. Phages replacing antibiotics. So basically viruses that attack bacteria. How promising do you think that is?
I think that we need more research in this area. I know that in Georgia, they had a strong research in this direction, and they were using phage therapy also on human side to replace antibiotics, quite successful. And now there are, of course, many initiatives and possibilities. The difference, phage is, an antibiotic. Antibiotic is very, very stable. It's a chemical substance, while phage, there are so many influences. Where does it come from? And then there are conditions. So it's not that straightforward. But using a specific approach and having enough research in place, and of course enough finance.
Sure.
Because antibiotics are great, incredible, but they're cheap. And if you talk about alternative, and then they need to be kind of a balance, especially for antibiotics where they are really needed, like African countries. I'm not sure, but it's also the availability of antibiotic or phages is a topic. You need to provide them to the price where that people can still afford it. That's where it's getting challenging.
Good. Yeah, let's move on to your trial.
Yes.
Your trial shows a very fast triggering of multiple resistances in E. coli to enrofloxacin.
Enrofloxacin, yes.
Thank you for the help on the pronunciation.
No problem.
How quickly could this happen in real world conditions?
Right away.
Right away.
You use antibiotics, and then you can expect that the population of bacteria gets resistant, because bacteria want to survive. They are like all life organisms, right? They are conditioned like they want to survive, and if there is a triggering part, and antibiotics are, and we need to think about antibiotics like historically. What are antibiotics? They're chemical substances produced by fungi or bacteria, and those fungi and bacteria were here for millions of years. So antibiotics are natural substances. And bacteria had to fight with them for many millions of years, so they know how to defend themselves. They have developed over this long, long period of time mechanisms how to defend themselves. The presence of antibiotic resistance per se is not a challenge. It's natural phenomenon, right? The challenge is the a very large amount of these antibiotics. And the mechanisms are developed, so it can work very fast if you just provide, a big amount of antibiotic of the substances. Then bacteria can respond quite fast and get resistant. And then, of course, you decrease the susceptible bacterial population, and the resistance is one that survive. And when the optimal condition, bacteria needs 20 minutes to replicate. So it gets very fast.
Yeah. So basically, we have genetic and microbial mechanisms that explain how resistances develop so quickly. And under these circumstances, we'll basically continue to search for substances that can overcome these genetic and microbial mechanisms that help bacteria to resist.
Yes, we try. But the best, in my experience, the best mechanism is to use less antibiotics.
Okay.
Yes, because
keep susceptibility high on the bacteria side.
Yes, and this is possible, and this is actually why it provides us help, because what helps? What we see what drives antibiotic to get resistant, but we also see that if you remove antibiotics, then the population in the gut or whatever ecosystem it be goes back. So the susceptible bacterial population is, getting more and more, and resistant get less and less. So we use antibiotic, then it's gone, and then we see a reduction.
So resistances roll back?
Exactly. That's why it is reasonable to reduce. Otherwise, if we just, there is no reason to reduce because resistance is 80%. So why to reduce? It's already 80%. Okay, we should reduce because it shouldn't go to 100. But the very positive message, it goes down. And we see it. It takes time, depending on antibiotic and resistance and so on. But it goes down for humans, but also for animals. And that's the most easiest way how to reduce resistance. Take antibiotic out, reduce antibiotic use. That's why everybody is talking about reduction of antibiotic use.
That's fascinating, because there's so much doom and gloom about this. People say, oh, all the microorganisms are going to be resistant to antibiotics at this point. But to me, that never quite makes sense, because you have such quick generations that it's likely that multiplying bacteria will lose a resistance at some point again. And you telling me that's the case?
Yes.
Yeah.
Yes, that's the case actually. Also with in my experiments, we were providing different kind of challenges to different bacterial population, and in general, I saw that the resistant bacterial population is more vulnerable to stress. So they have the reason could be a fitness cost.
They're working harder.
Yeah, because you need to have this all resistant genes. You need to carry it. You need to spend more energy. And if you have more energy to spend, then it's not that simple. Of course, it's more complex, because sometimes you have then another mutation to put the resistance cost down and so on. But it's still the case always. If we reduce antibiotic use, resistance goes down. That is shown by the huge amount of data in every monitoring study yearly, because now in Europe we have more than 10 years monitoring. Every year, what is the resistance rate? And then we know, okay, antibiotic use goes down. And then we see in this same country resistance goes down. And that's where we want to go.
So for producers, what's the lesson here?
Animal producers, you mean?
Yes.
To reduce antibiotics responsibly. So and it's possible, because even in Europe we have different countries, and then you can see this country use this much and this country use more, and many countries use more. It's not about the question who is using what. It's more to understand, okay, if they are able to reduce the use, then I can do it either. And interesting fact that in Europe we could reduce, such as the baseline 2018, now we have 2025. In general, we could reduce antibiotic use in animal production in Europe by 25% on average. Some countries, they were reducing 50% or 70%, right? So some countries are really, really good on that. And it means that it's possible to use that. And with that old reduction, we still do not see a very significant increase of the production costs. So it doesn't mean that if I reduce antibiotic use, I have a much higher production cost, right? So there are ways to use it responsibly, reasonably, with low risks, starting like we were supporting some accounts or some partners on the journey to reduce antibiotic use, starting where it is less risky, all the animals. And then evaluating the situation. Very, very, very important is not just, oh, I take this antibiotic and then use this, it is work, and this will work. So like exchanging the substances. It's not responsible. I need to understand, why do I use it, or what is the resistance level? How can, maybe it's a biosecurity issue that a producer has. It's not about then replacement. It's more to improve the biosecurity or some nutritional factors that influence. So what is causes stress, and there is a disbalance, right? And why do I need my antibiotic? To understand that and to learn from each other. We don't need to reinvent the wheel, right? Some countries did an excellent job with that, with many, like several decades of experience already. So with this intervention, connection, partnerships, it's very important.
I'm aware of a case study that a bird farmer was able to support 6 million animals without antibiotics use in perfect health. So there are clearly strategies for maintaining animals healthy without antibiotics. Talk us a little bit through that case study and talk us through these strategies.
Yeah, it was a pleasure. Thank you. Yes, the customer wanted to, because DSM and Firmenich Animal Nutrition and Health, we have solutions that we called alternatives to antibiotics, not for treatment, but for prevention of diseases. And then they asked me, hey, what should we use? We want to be antibiotic free. We need to be. And we use antibiotics like this and everywhere, this amount. So we were very transparent. And then we started to work together on the project. And of course, it's a very responsible part, right, to replace antibiotics. And then we took several step approach. So we made the first trial was just 2 million birds, run control group, and then the group with antibiotics, and then the group with our solutions. And then after the finish, we evaluated, was it the same, the performance the same? When it was not the same, what was the issue? Very important is the involvement of veterinarian. Of course, he's responsible for health of animals, nutritionist, so to evaluate. And if there are some, we can see, okay, there is a performance drop, so why? So in this case, there were some, we have discovered biosecurity issues that needs to be improved in order to continue. And then after the first cycle, we were confident, like, okay, we could continue. Then the second part, we could reduce the second part of antibiotics. And the performance was quite good in this time. And then with the third one, the level of performance was on the same level as of antibiotic group and our solutions. But it was like, carefully evaluated. Different stakeholders were involved to have like really no risk. And what was interesting for us, because when we were talking about the approach at the very beginning, and I say, hey, what are the costs? We were talking at the beginning, antibiotics are great, but they are also very cheap, right? And then if we come and say, oh, instead of this, use that, then they're like, okay, I'm not sure. But what counts is at the very end, if you have the performance and the evaluation of what was the kilogram of feed per kilogram of live animal, it was equal. So there was no cost issue at the end, but the producer was antibiotic free. He was very happy, and we were extremely happy because, this we see how it worked. And if we talk about antibiotic use, we do not only support one producer. Yeah, we contribute to the efficacy of antibiotics for human health, but also for animal health, but also for human health.
I imagine, because essentially being antibiotic free as an organism promotes better gut health, gut microbiome, obviously, because the bacteria gets to survive. I imagine there might be some very positive knock-on effects for the quality of the animals here in such a study or in such a production environment, which is completely antibiotics free. What do you think? Do you think that is a premium that producers can achieve by being completely antibiotics free through these tactics?
Yes, of course, there are some incentives. and the market, which some customers have, that non-antibiotic ever label on their products, so that they say this is produced without antibiotics. It's more for the consumer, because why is the pressure to reduce antibiotics? It comes from one side, very often awareness and willing to contribute. Another side, sometimes regulatory pressure, like ban of AGP. So there is no any other way. We need to reduce and remove antibiotic growth promoters, right? But also consumer, like McDonald's and so on of this world, say, hey, we will buy this product from you if you don't use antibiotics. And non-antibiotics ever is a production possibility where that attracts also consumer, also in the supermarket, that they know this product was produced without antibiotics. It's just important to understand what it is, because non-antibiotics ever doesn't mean that other meat has antibiotics, right? Like a substance in the meat. It's not. It's just the production. And it's also very important to mention that non-antibiotic ever is a possibility to raise antibiotics, but we also need to keep animals healthy. If they get sick, they deserve to get antibiotic, and that's not bad. It's the same for humans, right? If somebody gets sick and needs antibiotic, they should get antibiotic. Yeah. We shouldn't save there, right? We shouldn't say, oh, don't use antibiotics. So treatment is a different story. If animal gets sick, they get antibiotic. They maybe not to be sold as non-antibiotic ever, but it doesn't matter. They sold like a normal. For the consumer, there is a very big difference as such, because there is one issue of antibiotics residues in meat. Of course, if we eat meat, we don't want to have antibiotics there, right? But normally it's really strictly regulated. So the antibiotic needs to be, there is a withdrawal period. It needs to be provided to the specific part, and before slaughtering there is no antibiotic use. It's more that we use antibiotic, then we have a lot of resistant bacteria in the gut, and then it goes, of course, to the meat and environment everywhere. But normally we eat meat cooked, and bacteria are very susceptible to heat, right? If you cook the meat, all bacteria die, also resistant ones. So it's safe. Meat is a safe product for the consumer at the end of the day. It's a different story for raw meat, but if it's thermally treated, it's a safe product.
So talking about regulation around this and efforts to reduce antimicrobial resistance, on the level of the FAO or the EU, what type of efforts are ongoing there?
Yes, in general, there is, we call them, not we call them, sorry. There is a quadripartite leadership of the actions globally on the topic of antibiotic resistance. It means this is WHO, FAO, World Organization of Animal Health, and United Nations Environmental Programs. So these 4 organizations work with different stakeholders and experts and scientists to identify what is the right strategy globally, on a global scale, to proceed. Should we just ban antibiotics and that's it? Would it work? Is it reasonable? Is it responsible? What should be banned? What should not be banned? So they get kind of all this expertise from different stakeholders, and we are part of such a stakeholders. We sometimes, if we ask, we provide information what we know, or we are also participating in different research projects, like Avant recently was identifying what is the right antibiotic alternative. And then they develop a guidance or recommendations. With that recommendations, they go with different, they're connected, of course, with the Ministry of Agriculture in every country, and then they provide them to the Ministry of Agriculture, and the ministry has then the power to decide, what do I do in my country? Do I ban? Do I restrict? Do I it's not a priority or whatever, and that's why there are many efforts, because they are globally coordinated with the expertise, and many ministries work together. And last year, I had the pleasure to participate on the United Nations General Assembly meeting on antimicrobial resistance. And it was so impressive to hear the ministries of agriculture, ministries of health, the commitment to reduce antibiotic use. So they understand it's the issue that can be solved, can be reduced if we put our efforts. It's not a challenge that is not possible to solve. And with that commitment, they also made some actions. But I also hear very much like responsible voices. It's not about the ban or restriction. It should be reasonable. It should be supportive. And I think that's a very important point. It was coordinating efforts and, of course, contribution from many stakeholders. Yeah, just recently we were participating on or providing inputs for the FAO organized Renofarm initiative, which are developing like 5G. And one of the G is a good practices, and a good communication and good alternatives where we play a role as an examples, right? So it's important to have this global view, but local action. I think that's the key.
Mm-hmm.
You need to know what my neighbor is doing, but I also need to know how can I solve the issue.
Mm-hmm. In terms of action, there are two paths where we have to follow, it seems, at the same time. One of them is how do we reduce antibiotics. The other path is how do we develop new antibiotics that we basically can hold back for the ultimate human use levels.
Yes.
In recent years, we've seen massive steps forward in technology on the level of AI, machine learning, data processing. How does this help with these two different efforts?
I think it helps with the identification of substances, because what AI helps, I think it's acceleration of process, because all the trials that were time consuming in the past can be done much faster, and that's great. So I now a big hope on AI and also other supportive tools to have more antibiotics, because they are needed. I think if just this publication, when I think about that, between 2025 and 2050, 200 million people will lose their life because antibiotics are directly and indirectly not working. And that's a big number. We shouldn't go there, right? So we have the power to prevent that. And we know that, antibiotics is used on human side, and then, of course, it's the main driver of resistance on human side, but on animal side as well. And we need, to make sure that we reduce the use, and also develop new substances that can work. Because, especially for children, I think very, very important. So that we can rely on antibiotic in the future.
We are 35, just letting you know. Yeah. So what gives you hope that we're going to solve this issue going forward on a level where we, let's say, keep a truce going with microbial substances that might be harmful to us and animals? Also considering the advances we've made in gut health and the microbiota granularity we get these days on the level of gut.
My optimistic nature.
Yeah. Please tell us there's some science too.
Yes, I think we need to recognize that a lot was already done. The use of antibiotics was reduced, and there are all these efforts. It's kind of contagious. I see sometimes in the meeting, if somebody presents how they could reduce antibiotic use, how they were talking with producers and with nutritionists and pharma, and how was it, and then other people listening to it, they just want to do the same. And that's not, it's reasonable, it's helping them. And it's also kind of, it's possible. It's not too challenging, right? Because there are some tasks that we need to solve as humans that are like much more challenging. But I think it's really reasonable to make it responsible, to make it happen. Therefore, I believe that with all the tools available and knowledge, communication with each other, we will certainly progress to reduce antibiotic use while keeping meat production where needed available, right? Because it's a very important protein source for humans, not only proteins, but also other nutritional elements. But I think this balance, like growing human population, need more meat, but less antibiotic use.
Okay.
I think it's possible, reasonable, and we are active and we have so many success stories.
Excellent. Well, I'm looking forward to watching you making that possible step by step.
Thank you very much.
Thank you, Nataliya. I could talk to you all day about this.
Thank you.
But unfortunately,
Very
we have
nice.
to stop. So yeah, thank you
Sure.
very much.
Thank you.